Good evening, everybody. My name is Quien, and welcome to an intro to Java. So this will provide like a good basis for those who are new to Java, as well as provide a good review for those of you who are very familiar with it. So, and also this workshop will be primarily focused on code. So we will only deal with, so that's what we'll be like mainly talking about. So on to a bit of today's schedule. I'm going to talk a bit about who I am, a bit about Java, really briefly on IDEs, and then we go into the meat of what we are talking about today, which will be about like hello world, variables, reference variables, strings, and then we're going to talk about scanners, prints, as well as just we're going to take 10 minutes to go through this example, conditions loops, and hopefully we'll be able to go into classes and methods today. So aside from that, I want to talk a little bit about myself. Who is this Quien person? So I'm a second-year computer engineering student at McMaster University. So as a computer engineering student, I do two things. I code and I do electrical stuff. So over here, some of the electrical stuff that I have done is a PCB board, which I have wired, as well as I've also done a lot of stuff on like breadboards and like doing a whole bunch of stuff with that. I've also done a lot of coding things with Java, as well as I know Python and C. In addition to all of this stuff that I just do in school, I also really like to do 3D design. So I like to use Blender to make all kinds of cool 3D models. And this over here is a Power Ranger helmet, which I actually printed and then like painted over and stuff. So yeah, just a cool hobby I like to do. All right. So now let's go into what this workshop is really about. Aside from talking about me, that's not what it's about. Also, by the way, if you guys want to ask me questions about my program and whatnot, I suggest you go to tomorrow's panel, post-secondary panel. I will be there, and I will be free to answer any questions that you guys have regarding computer engineering. So, moving on. So I want to talk a bit about how Java works. So when you create a Java program, you will create this thing called a. Oh, that's right. Oh, by the way, are you guys able to access the slides? If not, just like please tell me. Just like message me in chat about it, or just like say it.
Yes, we can.
Awesome, wonderful. Okay. So, so the way Java works is that so you create a .java file, and this is where you create and program all of your stuff. And then when you run it, you compile it, and it becomes a .class file. Now this contains Java bytecodes, and what bytecodes are basically like language that the computer understands. And so these bytecodes are then sent into what is called the Java virtual machine. Now, the Java virtual machine is where the computer reads through all of your code, understands what it is, and sends you an output. Now, why is this? Now, that's good, but it's also really important for how Java works. And it's one of the reasons why Java is so popular. The Java virtual machine makes it so Java is portable because the Java virtual machine is a software. So that means I can put a Java interpreter in anything. I can put it in a computer. I can put it in an iPad. I can put it in a phone. And which is really weird idea. You can code on your phone, but you can do it all with this Java virtual machine. So as long as like a computer has this, it can run Java no matter what it is. So that's one of the reasons why Java is so popular. And another reason is object-oriented programming, which is something that we will get into a bit later into the workshop, so stick around. Okay, so now besides how Java works, I also want to talk about IDEs very briefly. So IDEs are an integrated development environment. And what we are going to use in this workshop for our integrated development environment is online GDP. Now, online GDB, I would say. Now, this is a online IDE, so it will be able to run Java. It will be able to compile it. I sent it just on the workshop chat. So please click the link if you want to work alongside me with this Java stuff. And now there are also a bunch of different IDEs, such as like IntelliJ or Eclipse or even like Dr. Java. But the reason I won't be going through like the installation of it is because like the amount of time that goes into installing some of this stuff is really long. They can take like upwards of like maybe 18 minutes to like an hour. So that is why earlier today I have sent a lot. I have sent a few tutorial videos. If you look on the workshop chat and you look at the pinned messages, you can see that I have put some tutorials for installing various IDEs such as IntelliJ and Eclipse, as well as one for Mac users. I use Windows, so I'm not really too certain, but I asked a friend and she told me to use this tutorial. So if you guys want to download an IDE later after the workshop, use those tutorials and they should be helpful for you. Now, if you have clicked the link for online GDP, please tell me so, and just make sure you guys have it over here so that way we can work through code together. So are you guys able to like click the link and like use it? Do you guys see this page in front of me, like a similar page?
Yes.
Wonderful. Anybody else? I'll go check the chat in case you guys are responding over there. Okay, okay. All right. By the way, does anybody have any questions so far? No, wonderful. Okay. So in order to test this out, I want you guys to also run it, and it should tell you hello world. And I just want to make sure that's good. You guys can all see that? Or like you guys are all able to run this code, the first code that showed up? Okay. All right. Sounds good. Alrighty then. So now we are going to start actually coding. Okay. So first thing we're going to do is we are basically going to highlight all of this and just delete it straight up. Now, the reason I'm doing this, even though we are going to go through, we're just going to repeat this code again, is because the best way to get better at coding is by practicing. What matter, like you can't just like read over a bunch of slides, or you can't just watch a bunch of videos. You have to actually code as like think like similar to like math or like a language or something. You need to practice in order to get good at it. So that's what we're going to do. So just follow along with me and just code along with me, and we'll be able to learn Java together. So the first thing I want you guys to do after deleting the whole thing is to comment. So do this double backslash over here. And what we're going to do is we're going to put our name. So just write your name in. I'm going to put mine as John Quien, and the date. Today's date is the 28th of December, 2020. Now, the reason why I'm writing this comment up over here is just because it's good coding practice to have like some kind of header at the top of your code, just being like, so that way anyone who stumbles to like looks at your files is like, oh, okay, who made this code? Okay, it was made by this guy at this date. So it's just good coding practice to have. Okay. So now let's go into some of the basic stuff for coding. So the first thing we're going to do is we're going to write public class main. And then we're going to put some curly brackets here. So the reason, okay, so let's break this down bit by bit. So this public thing over here is used to tell Java that this whole thing exists, because otherwise Java won't be able to see it. It's like it's like a sign to the Java programming. It's like, oh, okay, because it's public, that means I can see this thing, and that means I can use this thing. Okay, so the next part is class. And class basically tells Java, okay, this is where I am going to write my code. So over here, we're just going to have some code. And you don't need to write this comment over here, but it's just like illustration. And over here is our identifier, or like the title of our class, and we're going to call it main. You will also notice that main is the exact same as the file name. And this is important because if we have the class name as something different than the file name, then this whole file won't run. So for example, if I called it John and we run it, we'll run into an error. Yep, see, John is public, should be declared in john.java, not in main.java. So let's change this up, main. Okay. So now let's write ourselves a main method. So here's what we're going to do. We're going to write public static void. We're going to put lowercase main, okay, bracket, string, then a square bracket, arc. And then we're going to put a curly bracket over here and press enter, and another curly bracket should appear over here. Okay. Just making sure all of you guys good so far. It's like, I hope you guys aren't running into any issues. Doesn't sound like it, so I'll continue forward. So now let's analyze this. So as you can see, it's got the same public as it did over here, and it's for the same reason. We have public in this line so that way Java can see that this is the main method. Now also I should also mention that every Java project needs a main method. And you may think, like, why does it need a main method? Well, think of like a video game. A video game needs a main menu in order for you to select all the different game types and game modes and whatever. And Java is very similar. We need a main method for us to like manipulate variables, or for us to like work with user input and so on. So we need this main method here. This static void stuff, as well as this string arg stuff, are things that we will try to get into later on in the workshop. So just for now, keep all of this stuff in mind as stuff that we need in order to create our main method. Okay, cool. Alrighty then. So now let us move on to the next part, which is writing a output. So the main way to show an output to a user is using system.out.println. So we call the system class, we do .out, and we do .println. And what this does is what this print line does is it will allow us to, well, print a line, and it's just shortened to println. So let's say like hello world. Now it's important, by the way, whenever you want to print out a sentence, you gotta put it between these double quotation marks. So that way Java will understand that this is a sentence and that it should be printed. Because if you don't have these, then you will run into an error. And now we put one of the most important things, a semicolon. Now semicolons are one of those things that Java programmers will super easily forget. But these are very important for your code. Semicolons are basically like periods in a sentence. If you have an entire paragraph and there's no periods in it, it'd be very hard to read. And so it's the same thing for Java. We give it semicolons so that way we say, hey, this is the end of a statement. And so now we have created all of this. We should be able to run it. And bam, it says hello world like before. So does anybody have any questions, and were you guys all able to get it going? Just want to make sure you guys got it all good. Is it everything good on your end, everybody? Yay, awesome, awesome, awesome. Wonderful. Alrighty then. So congratulations, you have made your first Java code. Good job. So now we shall talk about variables. So variables are things that hold like data. So think about like how you might have a box, and in this box you would put stuff in it. And so the box is a variable, and the data we put in it is the stuff we put in the box. And for Java, there are specific boxes that hold specific types of things. So let's look over here at this. Oh, sorry. Let's look over here at this slide that I have. So there are different types of data types that hold different kinds of data. So let me show you one of them. So let's say I wanted to have a variable which hold integers. One of the data types I can use is called int. And the way we give it a name, the way we give the way we create a variable is by writing the name of our variable over here. So let's call this integer, let's call it just number. Okay, and remember to put a semicolon at the end of this. So what we have done just now is called variable declaration. It's where we give a variable, aka number over here, and we give it a data type. So this, we have declared our variable. Okay, cool, nice. But but variables are meant to hold values. So let's give this guy a value. So how do we do that? So the way we do that is we put an equal sign over here, and then we give it some kind of number. So it holds integers, so that's from negative infinity to positive infinity, no decimals. So let's just say 9. And so this equal sign, what this equal sign does is it assigns the value of 9 to the variable number. And assigning a number to a variable is called initialization. Okay, so let me just show you that this number has the value of 9. So system dot out dot print line, and we do number, and we do a semicolon, and we run it. Ah, nice. Okay, cool. So as we can see, this number holds an integer type. It held the number 9, and it does indeed. Now, there are also different kinds of data types for integers. So as you can see, we have byte, short, and long. But Java likes specific data types more than others. And so I suggest that whenever you have to deal with an integer, you go with int. Okay, so let's move on to other data types. So let's say we wanted a decimal number. The main one that Java tends to really like is a data type called double. Now, double is a floating point data type, which means that it holds decimals. So let's say we have a good decimal number that I really like, 3.14. And so we run this. Oh, main.6 Java. Oh, no worries, just a student. Just post the code in the workshop chat, or you can DM me it, and I'll take a look. I'm wondering if it might be a problem with the online GDP, or if it's just oh uh see, can I see it over here? No, it just sends me to the normal page. Could you perhaps take a screenshot of it? I don't think I'll be able to access your code using the link only. Thank you so much. So while that's waiting over here, so yeah, doubles carry double data types. All right, so what's going on? Oh, okay. So just a student. So I'm just taking a look over at his code. So, or her code. So let's see. What is error reach? Oh yes, you need another brace. So it's important that you guys keep in mind the brackets because so as you can see, there's a bracket over here, and the ending bracket is over here. And for main, there's a bracket over here, and there's an ending bracket over here. Now, sometimes it can be very easy to get them confused. Trust me, I know. So one of the ways that you can keep better track of the ending of your brackets is by putting a comment on them. So one of the ways that my teacher liked to teach me would be like, excuse me. Sorry, I just needed a drink of water. So one of the things that my teacher would like to do is he'd always put a comment at the end of his main method. So end of main method. And then he would put also a comment at the end of his main class. This is so that way you guys can just keep better track of of brackets. And if you really need to do so, then that would be good for you. And if you need to do so, then sure. If you don't really feel like they're necessary, then that's also completely fine. Sorry, my apologies. All right. So now let's talk about the last two data types, which is char and double. I mean, not double. Char and boolean. Okay. So char is meant to refer to a character. So let's say we have let's say we have a letter, and it's equal to bracket A. And when we print out letter, oh, that's not how you spell letter. When you run it, it will print out the letter A, and that's very cool. Now, char doesn't need to be like just letters. They can be any kind of character. So they can be like they can be like a plus sign, and you can run that. They can even be like a number, but you have to keep in mind that they must be between these apostrophes. Otherwise, it won't be considered as a character. Also, they can only hold one character. So if I put like 7A, I will run into an error. Exactly. Okay. So now let's keep moving on with the last data type I need to talk about, and that is Boolean. Now, Boolean holds true or false values. So if I have a Boolean, and let's say I'm trying to look for if I'm hungry, let's say. So let's say is hungry. Say it's and with the only values that a Boolean can be set to is either true. So let's just print this out. So is hungry is either true or false. It can't be set to any kind of integers or characters or anything like that. It can only be true or false. Now, one thing I would also like to point out is the way I have labeled this variable. You may notice that I have I didn't capitalize the first letter, but I capitalized the second letter. And this isn't because if I were to capitalize it like is hungry like that, I would run into an error. I won't. The reason simply is because it's just good programming. So it's just like good and clean programming. So when you create a variable, it is customary that you have your first word, the first letter of your first word, be lowercase, but every word after that be uppercase. So, like, I have the word is, it's lowercase at the front, but the word hungry is uppercase. And there's a bunch of other rules as to how to name your variables over here. So, one of the other big rules is that you can't put a number in front of your variable because you can't put a number in front of your variable because if you do that, then you'll run into an error. In addition, you cannot name your variable in reserved words. So, for example, Java uses a lot of specific words for specific things. For example, you can't make a data type your variable name. So, if I said I wanted my variable name to be Boolean, I can't do that. I'll run into an error. So, bam. All right. Does anybody have any questions so far, by the way, about just all this variable stuff? No? We're all good? Awesome. Okay. By the way, just feel free to ask any questions. I'm just like open to answer them. So, now with all of this stuff, let us talk about how we can manipulate the data in these variables. So let's talk about integers and a equals to 0. So let's say I got an integer, and let's say it's equal to 0. So a is equal to 0. So how would we change this a into, let's say I wanted to make this a 1. So I would just do a is equal to a plus 1. And you may think, hey, wait, hold on a second. That doesn't make any algebraic sense. A equals a plus 1 does not make any sense in like my math class. And you're right, that wouldn't make any sense in your math class, but it does make sense in Java. So the reason is that Java sees this as your variable, and this is an assignment. This is an assignment statement, not an equal sign. So what this means is that the variable is being assigned to the old value plus 1. And so when we do a system.out.print line, we print out a, and we run it. And we get 1, because 1 has been added to a, and so it becomes 1. Wonderful. Now, there are also many other arithmetic expressions that we can do more than just addition. Oh, I should also show you one way to quickly add 1 to a variable is by just doing a quick plus plus. And Java sees this as, oh, you're adding 1 to your variable. It's just like a shorthand. So as you can see, our variable was initially 0, and then it became 1. Oh, all right. So, do you have a question, Dion, or you just posting the code? That's fine. All right. So, let's move. So, there are also a bunch of other arithmetic operations that I would like to show you guys. So, one thing cool that you can also do is you can initialize and declare variables. You can initialize more than one variable in the same line. So you can say b is equal to 0, or let's say b is equal to, let's change the numbers up. Let's say a is equal to 2 and b is equal to 3. So you can declare variables on the same line if you use this apostrophe and then just put the variable. So let's just do some really basic arithmetic. So a plus b, that would be 5. And I'm just going to copy paste because I just don't want to do a whole bunch of system.out.print lines. And then a minus b. And then the way you do multiplication is you use this star button that's right above 8. And the way you do division is you do a backslash. So let's run this and see what happens. So as we can see, when we do a plus b, we get 5. When we do a minus b, we get like 2 minus 3, which is -1, so that's good. When we do 2 times 3, we get 6. When we get 2 divided by 3, we get 0. That's weird. That's a very strange thing to happen. When you put that in your calculator, you should get 0.6666 going to infinity. So what happened? Do any of you guys have an idea for what happened here?
Well, because both a and b are integers.
Exactly. So both a and b are integers, and so they can only hold integer data, and so they can only hold integer data types. So remember, integers do not have any decimal places. So what that means is that this cannot be a decimal. So what happens is Java sees this and it decides to round down. So even though this is 0.66 whatever, and you'd expect it to round up, it decides to round down. And this goes for any kind of integer division. So we have a couple solutions to this. One way is we could simply change one of the, we can change one of the variables into a double. And so when we run it, oh, I forgot to put a semicolon. See, very easy to forget. What happens here is we get the proper value. But you also notice that all of the other arithmetic became decimals as well. So what if I wanted the arithmetic to only give me integers? What other possible ways do we have to do that? Well, I'll show you. So one of the ways we can do this is through casting. Now, casting is this thing where we temporarily change a number into a different data type. So what we can do is and the way we do it is by multiplying the data type by a variable. So we run this, and we can see that it 0.66, whatever, into infinity, occurred normally, but all of the others have stayed as an integer. Wonderful. Magic. Well, not really magic, it's computer science. So we were able to make this into the proper decimals. It's also important to note when you do casting, what you need to do is you have to put it at the front of your variable. If you put it at the back, what's going to happen is that you will run into an error. Come on, program, compile. Do it. Do it. Do it. Do it. Huh. I guess it run into a really big error. All right, let's stop it for now. Oh, something happened. Okay, give me a moment. Let me just copy paste this code. See, let me run it. Yeah, reload, please. Okay. My apologies, everybody. Yep. So as you can see here, dot class expected, and so we ran into an error. So you got to make sure that you have your double in the front. Now, also, if we were just sticking with just straight arithmetic, we could say just like 2 divided by 3, just straight up. We could simply change one of the numbers into a decimal, and we would get a decimal result. Or we could put D or F. And the reason why D or F is because the data types for real numbers are float and double. Okay, so now there is one other arithmetic operator that is really important and that can be really helpful. And it is called modulus, AB, A%B. So what happens here is that you notice that what we get is 2. And the reason we get 2 is because what modulus does is it gives us the remainder from the division of two numbers. So 2 divided by 3 has a remainder of 2. 2. So, for example, if I had 3 over here and I ran it, our remainder will be 0. And as seen, our remainder is 0. So this is just something important that can be really important. Say if you were finding even numbers, you would get the remainder, and every even number would have a remainder of 0. So just something important to keep in mind. All right, so we went over casting, modulus. Okay, now we move into some really neat stuff now that we've gone over all of this variable declaration and initialization and whatnot. Does anybody have any questions, by the way, before I move forward? Okay, no? Awesome, awesome, awesome. Oh, also thanks, Dion, for posting that code. That'll be really helpful. Oh, as that person is typing, I'll just get started on talking about the next bit. Yeah. Okay, so our next part will be talking about... Oh, there's also one more thing I need to talk about in regards to casting right. See, these slides are also helpful. So one more thing I should also talk about in regards to... Okay. Pink, if you could just, if you want to still write your question, that's perfectly fine. I'll just make sure to come to it once you're done fully writing it. Okay. So one thing I want to talk about is in regards to char. So characters can be also casted, which is very interesting. So let's say we had a letter, and let's say we had A. Oh, okay, wonderful. Good job, Pink. So as I saw another person writing over there. If you want to just write your question in the chat, I'll make sure to come to it once you are done like typing it all up. Okay, so let's say we had a letter and we had an integer. So let's say this integer is called number. Let's say it's equal to like something like 90. So interesting thing about letters or characters is that they can also be casted. As you can see over here, I have written this little diagram. Chars can be casted into an int, and ints can be casted into a char. And the way this is done is by the use of the ASCII table. So let's look at a specific letter. So let's say capital A over here has a decimal, correlates to the decimal 65. So if we made number 65 and then we set letter and then we assigned it to char, so we multiply char and multiply it by 65, we're going to get thank you, Teton, for answering the question. So system.out.println, and we print out letter. What are we going to get? Oh, so I just got an expression. All right, I shouldn't do this multiplication thing. We get A. Perfect. And we can also convert it vice versa. So if this was A, and I did a number, and I multiplied int by, let's say, letter. Right, and we ran this, we get 65, which is, oh, well, to be fair, that was the exact number that we had. So what if I put 90? We get 65. Wonderful. Okay. And it's also important to note the order of casting over here. So everything can pretty much be casted into a double, but you can't cast backwards. So I can't cast a double into an integer. It's just not possible. So just important things to keep in mind. Okay, now I move on to the next big part, which is reference variables. So reference variables goes back to the idea I was talking before about, or goes to the idea of object-oriented programming. So object-oriented programming is the idea that we have an object, and inside this object is code which defines this object. So for example, like if you have like a cup and like you have all the properties of it, like, oh, it can hold water, it's made of glass, and like I can easily smash it against the floor. I'm not going to do that though. So like my glass is an object and it has like certain properties. The same things can be said for Java classes. They have properties that we can use in our own Java codes. So let's import one of these classes and let's use them. So the class we're going to use is called the date class. So what we're going to do import java.util and we're going to put a star. So what the star does is it basically imports everything in java.util. And so that's like a whole bunch of classes that we can use and we can put to our disposal. And these classes are what are used to make objects. So let's go create one. Let's create a date object. So I have the class date over here, and I have all of the methods that can be used inside of it. I also have so let me just go over here. Over here on the slides, you can find the website where you can find all of the methods for the date class if you ever choose to use it. So let's create a date reference variable. So we do date, and we put, so this is the name of the class, and then we write a name for our object. So let's say, let's call this today, and let's let it equal a new date. Bam. Okay, so what did we just do? So what we did over here is kind of familiar. We created a name for our object, and we created a data type, or in this case, a class, for it. So we have a today, which is a date object. And what this equals does, this equals basically says, hey, you are equal to this class. Or like it creates a better way to say it is it creates an instance of the date class. It creates an instance of the date object. And so what we call this, let's say, we call this instantiation. So this stuff over here, this is called instantiation. And so now, since we've declared a today object, a today reference variable, we can now use it for methods in the date class. So let's look over here. Let's look for one of the classes, and let's use toString. So toString converts whatever data today has into a string that we can print. So let's print out something. So system.out.print line. By the end of this workshop, you should get sick and tired of repeating this, but that's good, so that way you remember it. So then today dot toString. Now remember to follow the same syntax as it does over here. You can see that it is toString with a capital S, and it's got these two brackets at the end. So you need to put these two brackets and then that. So let's run this bad boy. And what do we get? We get today's date. Oh, I guess tomorrow's date. Huh, I guess we get tomorrow's date. That's strange. And so we get, I guess, a date. It's Tuesday, December 29th. This might be because I think like the date class, what it does is it goes get the day of maybe the day after, like it gets the date of the day after maybe. Or perhaps it's because the JDK is in some other like country, and so it's getting the date from there maybe. Either way, we still got a date out of it. So that's just a cool thing we can do with objects and stuff. We can use methods from that object and use it in our own code. Anybody have any questions so far? I know this concept is a little weird, so if you have any questions, please feel free to ask. Okay. All right, let's keep moving forward. Okay, so we're going to be covering a couple of different classes as we keep going through this workshop. So another class that we have is called the math class. Now, interestingly enough, the math class does not require you to import anything. It just needs all you need to do is call the class by its name. So let's look at the math class over here. And we have all of these different functions. Now, what do these functions do? Well, these functions do all kinds of like stuff that you would have on a calculator, but we couldn't do with like the normal arithmetic, like just multiplying by by adding or subtracting or whatever. So for example, you can get the cosine of an angle, or you could get random numbers. Let's run through a few methods and see how this math class works. So let's remove this. I'll actually just put this code over here in case you guys want to use it. I'll make sure to just, it's also on the slides as well, but it's only just an image. Still, I'll just put it over here. So, how do we call this math class? Well, here's how you do it. So let's say I wanted to get pi, and math has a really useful thing that allows us to get the value of pi. It's just over here. So what we do is we do math, capital M math, and we do dot pi. Notice that it's capitalized because it's also capitalized over here. So what we do is we run it, and we can see we get pi. So 3.141592653589979. So, okay, cool. So let's use at least one of the other methods. I've got a couple methods over here on the slides. So math.pow, which gives the power of a to the power of b. So let's say we have two variables. So let's just quickly write this over here. So let's say pow And let's do, let's say 4 to the power of 2, which will be 16. Wonderful. You'll also notice that this is 16.0, and that is because this math.pow gives us a double. So it's important to note this in case you ever want to store this value in a variable. So let's look at the math.pow function over here. You can see that over here on the side it says double. So this tells us that, hey, this power method over here gives us a double number, or gives us a double value. All right, cool. All cool stuff that we can do with math. And now let's move on to another reference variable that we also don't need to import. And this one, so let's just actually get this out of the way to remove confusion. Okay, so now we are going to talk about strings. So strings are a string of characters, and they are very similar to primitive variables, but they're not the exact same. So look at this. String name equals, let's say, John. So hey, this looks exactly like what we would do with a primitive variable. We have a data type, we have a variable, and then we have it equal to some data. And that seems super weird because that's unlike what we did with the date reference variable. But this still technically counts as a reference variable, which is very interesting. So what we have over here, we have a name which has been assigned to the value. Oh, would you do okay, Dion has asked a question, and whether or not I would do a times a times a, or math pow, uh, 4. Um, Personally, I would stick with power. Yeah, I would personally stick with power because, like, if I was writing some kind of, if it was fixed, um, if it was fixed for, like, I needed to do something to the power of 4, maybe I'd multiply it 4 times. Say if I was like trying to save on like space on my computer, because like calling classes can sometimes take up space, and calling methods can take up like memory. But otherwise, I would like to just do math.pow because it's just easier to type and it just like it makes sense. But you can still do like a times a times a. It's more so up to preference, as well as if they say like, oh, you have a specific amount of memory you must use. Okay. So good question though, by the way, good question. So anyways, let's say we print this out. So system.out.println, and we do print line of the, oh, something happened. Get away from me, you damn, just got an ad for just my antivirus software. So we say name, and we run this, and we will just get John. So it's very interesting. Now there's also some other cool things that we can do with a string. So cool things that we can do. We can concatenate. What concatenate means, it means to combine things together. So let's say I had another string, and let's say I had it be my last name. So my last name is Quien, which is kind of weird to look at. Which is like, it's weirdly pronounced that way. It's Spanish. So what we do is we can add these two words together. So if we do the name plus last and we run it, what happens is the words are combined. So we now have John Kien, and we can also assign this to a variable. So for example, if I said last is equal to last plus name, do last, could print out last and run it. Oh, taking a bit. I get Kian John because these two words are combined. Now, this doesn't stop with just strings. We can also combine other things. like integers. For example, I can add like 17. So that's very cool. But you can't you can't just add you can't add two random data types together. It has to be added with at least a string. So, all right. So as I said previously, string is a reference variable, which means that it has a bunch of it has a so and reference variables have they have methods to them, as we've seen with the math class and as we've seen with the date class. So we also have a bunch of methods that we can use. So let's just use one of these for the sake of time. So what I can do is there is a length method which will allow me to print out the length. So name.length. We put brackets over there, I think. Yeah, I put brackets. This can also be seen on the Oracle site over here. I believe I have a link to it. Yep. And so we can run that. Yep, and it gives us 4, which is the exact length of my name. All right, cool. So these are all the cool things you can do with string. So anybody have any questions regarding string? If you need to type it in chat, just do so, and I'll look at it once you have it completed. All right, nothing? Wonderful. Let's keep on moving forward. So now one more reference variable. I know I've been talking about reference variables for the past couple bit, and I've been saying it so much, but don't worry. This is the last one. Well, second last one. So with all of this in mind, we can now, there's one reference variable that allows us to get user input. So I want you to follow my syntax very carefully here. So what we're going to do is scanner user input equals new, not capital, new scanner. And in between these brackets, we're going to put system.in. Okay, cool. We have made a scanner class, and the scanner class allows us to take in user input. Well, how does it do this? Well, what better way to show it than with an example? So let's say we have an integer, and let's say I want you to input your age. So let's initialize it to 0. So int age equals 0. And then what we want to do, age is equal to user input dot next int. Let's put a bracket. So this method over here allows us to get input from our user. We should also mention, I should also put at the top over here, it's also important that we ask for the user's age. So please enter your age. And what we're going to do is we're going to then print out system.out.println the age. Okay, cool. So we run it. So what's going to happen, it will ask us to enter our age. So we do 19, run that, and it prints it out again, prints out 19. Wonderful. So we are able to get an integer using user input. Now, what if I say asked for a person's name? How would I do that? Well, for each data type, there's a different method for scanner. So if I wanted to do a string, and let's say this is our name, let's say it's equal to null. Null is basically like a 0, but so null is basically like a 0, but for like a string or for an object. So instead of writing next int, we just write next. And we should also change this to name. Please enter your name. And we will also print our name. So you run this bad boy. So my name is John. And we get John back. Awesome. Now there's also one thing I want to mention when you use this method for strings. So say I had something over here that was John Quien. Now, if I run this, what you'll notice is that it only prints out John, and that's because when you use .next, it sees any white space as the end of a string. So whenever I have a space, it sees, okay, that's the end of the string. I only need John, and then I just print that out. So that becomes the value of name. So is there a way to go around this? Yes, there is. What we do is we do .next line. And so what that does is it will allow us to put spaces in our answer. So if we do John Quien, I can print out John Quien. Very cool. Now there are also various other specific data types. So let's scroll down over here. So there are different methods, each for each data type: long, float, next double, and so on. So all important things to keep in mind. Now for the final, so now for the thing before we get into our example, I want to talk about prints. So actually, let's keep this over here. So actually, I'll put this also in the chat in case you guys might want to refer to it again. So now there are different kinds of print methods. So there is print, and there's also printf. So let me just talk about print real quick. So print is basically the same as print line, except you don't go to the next line. Here, I'll show you. So what happens is I write in John, and oh, it went to the next line. Oh, I think that's because of this. So I run this. Actually, better yet, you'll see that unlike before, I was writing my name over here in this space, but now I'm writing my name over here. And that's because this print does not go to the next line. So now we're still writing on the same line. So we write our name, John, and it prints out over here. I guess .next already gives us a next line to work with. Okay, so just something to keep in mind. But the main thing I want to talk about is printf. Now, printf has a really important feature that allows us to very easily print out sentences and words and whatnot. So let me show you what I mean. So there's a couple ways that we could print out like this word. So this phrase. So like your name is, and then what you do is you add name to it because that's just some concatenation. Then we run it. Please enter your name. Name is John. Your name is John. Bam. Good. Very cool. And you can also do this with a print. Now, the way we can do this with printf is we can say your name is, and we put %s. Oh, and then we put a comma over there, and oh, and what this does, I'll get to your question in a bit, just a student. So what this does is name. So what Java sees is that using printf, we can see this %s, and what happens is name takes over this %s. So let me show you what I mean. Let me also change this back to a line. So run it. And then let's say I enter your name. My name is John. And it says your name is John, similar to how it was run previously with the concatenation. Oh, okay, so just a student, I'm gonna look at your thing and see what the issue is. Below is my code for a user input for a string. Uh, hmm, looks pretty okay. Yeah, what is the error you're getting? That's important. Good for asking that liquid LCD. Uh, hmm. Oh yes, it's important that you have a scanner for sure for this. Yeah. Well, it appears all the other guys are kind of helping you out. I'm a bit on a time crunch right now. Well, no, I'll still continue to help you. That's important. So name equals null, system.out to print line. Please enter your name. User input dot next line. Name one. Now that seems fine. Yeah, I think sending the entire code might help out. Right, I'll continue a bit of my lesson for now. Okay, so what else we can do with this printf, and the most important part, is we can also round up with decimal places. So if I wanted a double, and let's say I want, please enter like a cost of an item. So let's say double is equal to, let's say, cost, and let's equal this to 0. So let's say cost is equal to user input dot next double. So what we do for doubles or floating point, or like decimal numbers or floating point numbers, is we do %f. And the way we are able to round is by doing 0.2. So what this will do is it will round to the second decimal place. So if we put cost and run it. So we enter the cost of an item. Let's say the cost of my item is 3.1415, and it rounds up to the second decimal number, 3.14. And this is really helpful for, say, like just like for any kind of code, because you don't want all of these decimal numbers, because that can be a real big pain. And also this can be really helpful for printing for like just giving output to the user. Okay. So does anybody have any questions so far? Oh, also just a student just looking at your code right now. Well, that might be it. I'm not too sure though about if args or arg really matter. I don't think that really matters. Oh, args might matter, I guess. Okay. Well, I'm thankful to all of the other participants here who are willing to help you. Thank you so much. So, all right. Also, so now that we've gone this far into the workshop, I would like you guys to also just try this example that I have. So with all the knowledge that we have so far, I want you guys to make a Celsius to Fahrenheit converter. So it must ask for Celsius input from the user and give the Fahrenheit temperature up to 2 decimal places. So the equation for getting Fahrenheit equal to Celsius is Celsius multiplied by 9/5 plus 32. And so this is what you need in order to change Celsius into Fahrenheit. I want you guys to make a code which converts Celsius to Fahrenheit and allows like user input, and allows the user to input like what the Celsius is, and then it prints out the Fahrenheit. So yeah. So please go ahead with that. I'll give you guys 5 minutes to just like work on that, as well as I'll take this 5 minutes to just answer any questions that you guys have. Right. Also look at your problem over here. Yeah, this cup is empty. I brought 2 cups because usually if I talk too much, I'll get really dehydrated. Okay. So let's look over here. So at around like 10, 12-ish, we'll go I'll take a look at this example, but in the meantime, just try your hand at trying to solve it. Hmm. Interesting though. Perhaps this student, this oh, just a student. Were you able to get it? All right, don't worry. I'll look into it too. Hmm. So just don't mind me. I'm just gonna copy and paste the exact code that the participant has. Okay, user input. Let's see, how fast can I write? Hmm. Print line. Okay, I think that's most of it. Oh, I just typed it. I'm sorry, I didn't see it in time. My bad. He's just, okay. So let's see. Already asked for my age, so 19. Oh, yeah, that's interesting. It just stops right in the middle. Hmm. Perhaps it's because I have called string at the bottom over here. Hmm. Yeah, it is interesting. It usually is supposed to call more than one line. How strange. Okay, just let me copy paste his code because otherwise this might just be a problem with online GDP because sometimes it can just do that. Okay, so let's remove this part. This isn't what I'm after. Oh yeah. Hmm. So I'm not exactly too sure of the problem. If some of the participants may have the answer, I'll make sure to mention it later. But for now, it's been about 5 minutes. So I am going to, so what I'm going to do is I'm going to go through the example that we just had. So since we're on a bit of a time crunch, I'm just going to go through it. So for a Fahrenheit to Celsius converter, what I like to do when I think about these kind of questions is I like to think about what kind of variables I need. So we need something in order to get the Celsius, and we need something in order to get the Fahrenheit. So that means we need two variables, as well as we're going to need something for the user input. So for user input, we get scanner, user input equals new scanner system.in. And then, so we need two variables. And since we have a division thing over here, I imagine that we should put them as decimals. So let's say double, let's say Celsius equals 0, and Fahrenheit equals 0. Alrighty then. So then let us do another. So then what are we going to do over here? We're going to ask the user. So it's always important when you do this kind of stuff to just ask the user. So we ask the user for Celsius. So please enter the temperature in Celsius. And then, so what we're going to do is Celsius. That's not supposed to Celsius. Is equal to new, not new, user input dot next double. And so then we'll be able to get the user input. Now it also says we need to give the Fahrenheit. So this is the calculation for Fahrenheit over here. I can pretty much just copy paste it. So Fahrenheit equal to that. And then what we're going to do is we're just going to system.out.printf. And we're going to use a printf because it says it wants it to 2 decimal places. So what we're going to do is we're going to be like temperature in Fahrenheit is percent 0.2 F. And then we're going to put Fahrenheit. Okay, and this should be our working Celsius to Fahrenheit converter. So let's run this. Oh, I must have missed something. Oh, I spelled Celsius wrong. Did I? Wait. Cannot find simple.
I think
So.
we got the multiplication symbol.
Maybe. Celsius, like the multiplication over here.
Yeah.
Okay. Yeah, that's it. Okay. Yeah, you're right. Thank you. So, one cool thing to determine is if Celsius and so one cool thing about Celsius and Fahrenheit is that at -40, both Celsius and Fahrenheit are the exact same. So if we do -40, we get so that's interesting. We get -0.8.0. So can anybody tell me where the problem lies over here? So let's see, we're able to input it, right? So then there must be a problem somewhere over here. Can anybody tell me where it is?
You're still trying to divide 9 by 5, which are 2 integers.
Yes, exactly. So you're completely right over here. So because I'm dividing by 2 integers, what we're going to get is an integer value. So it will be like, let's see, 1.8. Well, it won't be 1.8. It will be 1. And so it'll be -40 plus 32, which is -8. So in order to do this properly, we need to change at least one of these into a double. So we put 0.0, and yeah. So if we do that, so we change this into a double, so this becomes a double arithmetic. So we put negative 40. And yay, temperature in Fahrenheit is negative 40. Well done. This is a very cool example. I'll leave the solution over here. Alrighty then. Oh, nice. Thank you, Dion, for helping Just a Student. So the way they were able to fix Just a Student's problem is by creating two scanner variables. So one for the string and one for the integer. So that was really neat. Okay. So now, oh, I deleted everything on accident. So now, all right, we don't have too much time left, so I at least want to cover ifs. I'm sorry that I wasn't able to get to as much as I wanted to. But let's at least go into the conditions. So let's say I have two variables over here. So integer a equals 0, excuse me, and b is equal to 0. Well, actually, let's change these numbers a bit. B is equal to 3. And these are important for our example over here. Oh, yeah, I should also ask if you guys have any problems with the last example. No? Yes? No? Yes? No? No, okay, we're good. All right, moving on. So we have these two integers over here, 2 and 3. Now what I want to do is do a whole bunch, just do a couple of conditional statements over here. So these are some of the conditional statements that we have, and they will give us a Boolean result and basically tell us whether or not what the statement is true. So for example, if I have system and I ask if A is equal to 3. I mean not 3, but equal to B. So this equals sign. So this statement over here is used to compare whether or not A and B are equal. Now obviously we know that, and so since they're not equal, the result we get is false. Now we can also ask if A is less than B, which is true. And we can run this, and we can see that what we get is true. And there are a bunch of different operators, such as less than, or greater than or equal to, or less than or equal to, or not equal to, and so on. And I suggest that you guys practice these in your own time as well. So the next part. But what if I had two conditions? Let's say I had a third variable over here, and let's call it C, and let's make it equal to 4. And let's say that A is less than B is less than C. And this makes total sense. It's like it makes complete like syntactical sense to us, but to Java, it does not. It runs into an error because what Java likes to do is it only likes to compare two things at a time. It doesn't like to compare like three things all at once. That's not what it likes to do. So is there a workaround to this? And yes, there is. What we have over here, let me find out what slide am I on. Okay. So we have an AND operator and an OR operator. So as seen on these slides, an AND operator will be true if both conditions are true. So if condition 1 and condition 2 are true, then the entire thing will be true. For an OR operator, if condition 1 is true, then it doesn't matter if condition 2 is false. As long as only one of them is true, then this whole statement is true. So let's look at this in action. So let's say I had B is greater than, so let's say A is less than B and B is greater than C. Now we obviously know that B is not greater than C, so this is false. But this over here is true because A is less than B. So when we run it, what happens is that it is false because even though this first statement is true, this one is false. So therefore the whole thing is false. Now let's move on to an OR statement. So an OR statement can be written with these two lines. and they're just above the shift sign. I know they're a bit hard to find. So, excuse me. So when we run these, we get true, because even though that this statement is false, because at least one of them is true, therefore this whole statement is true. Okay. Now these are important conditional operators for when you deal with ifs. So now what I want to do is I want to pull back up our previous example with the Fahrenheit to temperature converter. So I believe I had it somewhere over here. Oh, yeah, very nice editor, by the way. LCD, liquid crystal display, just showed off his answer. All right, very cool. Oh, you created a method too. That's so nice. Awesome. So, unfortunately, we might not be able to get into methods with the time that we have. But let me just get back our Fahrenheit to just give me a second, LCD. I'll get back to you in a moment. Okay. Yeah. For right now, we don't have to deal with creating more methods because it's just beginner code. But is it recommended to port conversion part into a method? If you want to. Like definitely making things more modular is good for code. But right now, since it's just beginner stuff, we're just going to go over like making the code all in main. But modularity is definitely good. So, all right. So let's go back to this Fahrenheit temperature converter and let's put some if statements in here. So an if statement is written like this. So what we have is if, and over here in these brackets, what we're going to have is a condition. So in this condition, let's say if the temperature is below 15 degrees Celsius, we'll tell the user to put on a coat. So let's say Celsius is less than 15. I'm going to do is system.out.print line. I'm going to tell the user, hey, put a coat on. Now I know for some of you that might not be super cold, but hey, I'm very sensitive to cold over here. I know I'm Canadian, but still. Oh, right. I still had the error from previously. I'll make that change on the thing. So if we enter our temperature in Celsius, so let's say it's 10 degrees outside. Oh, right, that's also important. So it does say, hey, put a coat on, but you also notice that it's all on the same line. And that's because I didn't put a next line in this print statement over here. So what we can do is we can put a /n, and what that will do is it will give us a next line. So when we run this, say the temperature is 10 degrees Celsius, and it tells us to put a coat on. Nice, nice, nice. So this is one way to write an if statement. Okay, very cool. I think I have time for also else. Okay. So in addition to if statements, there's also something called an else statement. And what an else is basically a catch-all. If this doesn't happen, then else will happen. Think of it like this will happen or else this happens kind of thing. So what we're going to do is we're going to have brackets. And so if the Celsius is not less than 15, we're going to say that, hey, it's good weather outside. Or at least it's hot weather. Yeah, it's good weather, good weather. So now we have, so basically, enter the temperature in Celsius. So if I say it's 30 degrees, it will tell me it's good weather. But if I put it at like 0 degrees, it will tell me to put a coat on. Okay, so this is good. We now have an else statement. We have an if statement. Okay, nice, nice, nice. All right, have about 2 minutes. Let's see if I can squeeze an else if in. I don't know if I have. Yeah, exactly. So if somebody puts in like 100 degrees, what's going to happen? So obviously 100 degrees isn't really possible. Or like if it is possible, then that's really scary. So we should put some kind of cap on that. So let's say if what we can have other conditions in our if else, so in our if statement. So we can write if else. And what this if else will allow us to do is if this condition does not work, then we can have another condition that will check Celsius. Okay, so we do Celsius is, let's say we want to tell if someone's putting like temperature greater than, let's say if they're putting some ridiculously high temperature. What's ridiculously high? Anything greater than I think 35. I think over here in like Ontario, I think that's really high temperature and just really bad. Yeah, I think plus 40. Yeah, 40 is good. Yeah. So just tell them print line. Yeah. Yeah, so we'll tell them that it's just really bad weather. So if it's greater than 40 degrees out there, say that's like that's a lot of heat warning. So we run that in. Oh, I got an error. I think it's because I spelled Celsius wrong. Did I spell Celsius? I spelled Celsius right. If else. Oh, right. It's not if else. It's else if. My apologies. So else if, and we run this. Come on, online GDP, work with me. All right, it's having one of those days. Let me restart it a bit. Don't worry, I copied my code. Sorry if I'm going a bit over time, organizers. So if we run this, so now let's put the temperature at like 100 degrees, which would be way too much. Say just really bad weather. All right, so this is just, yeah, exactly. So this is just some very basic use of if statements. So like just if else, and so on. So we've already reached 10:30, and I'm not too sure, and I don't think I can really go over time, but don't worry, that's perfectly fine, because everything else that I was going to cover, they are pretty much all in these slides. So elf is, for loops, arrays, and then it goes into the beginnings of classes and stuff. So
Hey John, so you can go over time if you wish, and if people wish to stay here afterwards, that's completely fine. Maybe just like do a quick wrap up for those who can't stay later, and then if you want to stay later and they want to stay later, we have no problem with that. That's fine.
oh, okay, all right, okay, cool. So, so if you guys have, I know the end time said 10:30. So if you guys need to go somewhere or need to like get to work on something else, that's completely fine. Uh, don't worry, there are these slides, and you can refer to these for any other like content that goes beyond what I have covered up to this point, and that's like perfectly fine and good. But if you want to stay around, I will continue to go over some of this stuff, to go over loops and at least up to and arrays, and then up to classes. So if you so if you have something else to like do, that's perfectly fine. You're like free to go. But if you want to stay around for some more Java stuff, then I'd encourage you to just like stick around. Yeah, let's Java all night. All right, in which case I'm gonna go grab a glass of water. Yeah, I'll be back in like 5 minutes. I'm back. That's fair. That's fair. Okay. I'm glad you guys are also willing to stay. Thank you so much. Alrighty then. Okay, so now that we've covered the basic stuff of if statements, as well as reusing our example over here, let's go and talk about loops. So naturally, we'd want to use loops whenever we'd want to repeat our code. Say when we want to say we have just a bunch of lines we want to print, and just we don't want to do like system.out.println like 50 times. So we use a loop because that's a whole lot easier. So let's go through an example over here. Let's just remove this for now. Actually, I'll copy paste this and put this on the chat again. So what we're going to do is we are going to, all right, so let's now do a loop for a factorial. So a factorial is this thing where we multiply all the numbers below the factorial number. So if I say the factorial of 3, that would be 3 times 2 times 1. Or if I said the factorial of 5, we would say 5 times 4 times 3 times 2 times 1, which is 120. So let's say we have an integer, and let's call it factorial. Let's say it's equal to 5. So we want to get the factorial of 5, but or let's say like we wanted it to be, let's make it a user input because that will make this a bit more interesting. Scanner user input equals new scanner system dot in, and then we do an integer, we call it factorial, and we set it equal to 0. So then we ask the user, so the user will input a factorial number. So factorial user input. And we want it so that we have a loop that runs so that way it multiplies every number in that factorial. So what we can do is we can make a for loop. So how this works, we write for, and we put I is, oh right, we also need to declare I. So I equal to 0, and then we put a condition. So oh wait, hold on, this is not right. User input dot next int. And then we do factorial, and then we do I plus plus. So, all right, so what is this thing that I have just written down? Okay, so here is what it all means. So this is our initial condition. What for loops are used for is they're used to repeat through a code a specific number of times. So what we have over here is the initial value for I. So we set I to 1. And over here we have a condition. We have I is less than or equal to a factorial. So say that factorial number was 5. So what happens is that as long as this condition is true, this code will run. So let's say there's some like code over here. And then when this code runs, it then adds 1 to I and compares I with the factorial. So here's how that's going to work. What we're going to say is that new variable for this. Let's call this one. Yeah. Yeah, factorial. Let's just call this one factorial 2, because I need 1 for the input and I need 1. Actually, let's just call it input. There we go. So we just use this one as our input. I'm sorry, my apologies. And then let's use this one as input as well. And what we're going to do is we're going to make factorial equal to factorial times I. And then we're going to do, and just to show you how many times this does loop, I'm going to do system.out.println I. And then we're going to print By the way, don't fill up the workshop chat with too much text. I'm worried that like a person might have a question. So then we are going to print out factorial. Okay, cool. So let's run this. Oh, all right, I forgot to put the brackets. All right, I didn't put a print. So then we're just going to put an input, let's say 5. And it prints out 120, which is the factorial of 5. So as we can see over here as well, these are the inputs from this print line. We can see that it goes 1, 2, 3, 4, 5. And that's exactly the amount of times that we wanted it to go through. So what it does is that after each loop, it increments I by 1, so this becomes 2, and it compares it to our condition over here. So when it's 2, it's still less than or equal to 5, and it keeps doing that until I becomes 6, and then when it becomes 6, what happens is that this condition is broken, and so the loop is exited, and then we print out the final factorial number. All right. So does everyone kind of get that idea for a for loop? Just checking, does anybody have any questions for that? Yes, no? Okay. Well, it doesn't appear anybody has any questions, so we'll move on to the next loops. There's 2 loops I still want to cover, and that is the while loop and the do while loop. So let's make another code over here. So let's say we have an integer called quit, and let's set it to 0. So let's say we had a code which basically continued as long as quit did not reach a certain value. So let's say that while quit does not equal 1, this loop will continue, and then we do quit equal to user input dot next integer. All right, so when we run this, all right, I should also say, we should also tell the user to just like enter 1 to exit. Okay, so we run this. So if we enter 3, the code doesn't end. If we enter 4, the code doesn't end. But when we enter 1, the code ends. And that is because quit should not equal 1. And so when it does, we get out of this loop. Now, the main reason why we use while loops compared to for loops is because for loops are more so for a specific amount. We want this code to be repeated this specific amount of times. While loops are more so for like code that we don't know how many times it is to be repeated. So in this case, like with getting out of the code, I could repeat this code for an infinite amount of times or for 0 amount of times. Now, I should also talk about do-while loops. Do-while loops are very similar to while loops, except they have a key difference. So watch carefully. So do-while quit is equal to 0. So let's say enter 0 to exit the code. So let's run this.
Pardon me, there's an error in your code. So while quit is not equal to 0, it'll run. I think you meant quit is equal to 0. Right?
No. No, that's perfectly fine.
Oh, okay.
Because when we enter 0, our code quits. And also, if we were to run it, and if we were to enter like 1 or 2 or whatever number we want.
Yeah, I get
that's
it.
a bit too big. That's a bit too big.
Yeah, I guess it's bigger than an integer, but yeah.
Yeah. So what matters is that as long as we enter 0, the code exits. So now, how come that works? Well, this works specifically because the condition is checked at the end. So if this condition was checked at the beginning, then this code would not run at all. So let me show you what I mean. Let's copy this. Let's go back to the original while loop. So if I said enter 0 to exit the code, I already have quit set to 0. So if I do quit does not equal 0, this condition is already false because quit is already 0. So this whole block of code doesn't run at all. So if we run it, nothing happens. And then put that in comparison with our other code. If we do this, we are now able to enter 0, and we can exit the code. So these are just some key differences. What matters just here is like when your condition is checked. And so whether you want to choose one or the other kind of depends on how you make your code. Yes. Yeah, whatever is in a do while is executed at least once. That is true. Thank you, LCD.
Yeah, it always iterates once.
Exactly. Yes. Thank you so much. All right, so now we've gone through loops. And now we will talk about one of the last things before we get into classes, and that is arrays. So an array is basically a list of variables that we want, or like not really a list of variables, but more so a list of data. So let's say so here's how you write an array. There are a couple ways that you can declare an array, but there's a couple ways that you can declare an array, and there are also many ways to initialize an array or instantiate an array. So first you need the data type, and then you need the name of your array. So in this case, let's say I have a group of friends coming over to my house, or actually, no, not a group of friends coming over to my house. That's bad because it's COVID-19. Let's say a group of friends coming over to my Zoom call, and let's say we have names of these people. And so in order to declare this as an array, we need a square bracket. Now the square bracket can be pretty much anywhere. So you can put it over here, or you could put it over here, or you could put it over here. But what matters is that you just have this square bracket. And now there are a couple ways we can instantiate this array. So I want to show you some of them. So the first way is to, let me show you the syntax, is to do it like a reference variable. And so what we do is we write new, and then we put the data type, and then we put another set of brackets over here. But it's also important that you put the number of data that you want over here. So let's say I have 3 friends coming over to this Zoom call. So let's put their names in. So the way we put the names in, or the way we index through an array, is we start at 0. So the way that a array is looked at by Java is the first index is 0, second index is 1, third index is 2, and so on. So remember, counting always starts at 0. This is always something to remember because like sometimes you make these big codes and like sometimes you forget, oh wait, it starts at 0, I need to change some conditions around. So it's important stuff to keep in mind. So names 0 is equal to, let's put a name over here. So let's put my name, John. Now let's get another name. Put 1. Let's say Jake. There's going to be a bunch of J names. Names 2, and let's call it okay. So these are our 3 names over here, and if we run it, we can see that this whole thing works fine, and that we have, and we can also see these ourselves. So system.out.println. And if we print out names 0, what's going to happen is we are going to print out John. So, yep, we print out John like normal, and that's good, and that is good. So that is one way we can instantiate our, yeah, that's one way we can kind of like instantiate our array. But there is, or like assign values to our array. But there is also another way. And I think this way is a bit easier, especially if you already know what data you want in your array. So what we can do is we put these curly brackets and we write the names directly in here. So we put John, put Jake, let's change things up. Let's put Jojo. All right, print out 0, and we still get John. So these are just some different ways you could create your arrays. So now let's talk about some cool stuff that you can do with them. So they kind of look like reference variables, and that's because they also kind of are. So that means they have a bunch of methods and stuff that we can use with them. So for example, if I did names.length, I could get the length of this array. And so it will give me 3, which is very cool. Now, there's also another thing that I should talk about in regards to arrays, and that is copying one array into another array. So let's say I had another string of names, and this is for another Zoom call. Let's call this names2. And let's say it's the exact same as the other one. So let's just make it equal to names. So what happens is pretty interesting. So let's say I set names to at 0. Let's say I change the name of a person in the second Zoom call and I change it to Joseph. Now, interesting thing happens when I print out names, the original names variable at 0. You would think that it would print out John, but that's not the case here. It instead prints out Joseph. So why does this happen? Why does it do all these things? Well, it all has to do with memory. You see, let me show you my little illustration over here. So the reason is that these arrays will point to the same memory, and so a change in one array will occur to the other. So when we make an array, it creates this array in memory, and names basically is assigned to this memory block. But once we make names equal to, but once we made names2 equal to names, they are now pointing at the same memory block. And so a change in one will cause a change in the other. And this is really important, especially when you do stuff like this. So then how can we easily copy one array into the other? Well, it doesn't matter actually, LCD. For example, you can put it like this, and you can put it also like this, and it runs fine. So you can have it in all different kinds of ways. There are various ways to iterate it. Yes, that's right, William. So you can also write it like that. It just matters more so on preference. The way that I was taught is I had the square brackets at the front. So it's all a matter of preference on how you do it and how your people teach it. At the end of the day, you still make the same code. So anyways, back to the big question over here is, how do I copy one name into one array into the other? So here's what we can do. We can create a for loop. So we can initialize I to equal 0. We can also create the variable directly in a for loop because, hey, helps out. So I is less than names.length, and then I plus plus. Okay. So what happens here is that it goes through each array, and since these are both the same size, what we can do is we can do names to I. So what I will do is it will index through each array, or like, so let's say actually, let's make this new string 3. So that way it's the same length as the other one. That's why it's the same length as names. And make this equal to names at I. And then what's going to happen is if we do names2 at 0, change it to Joseph. And then we do system.out.println and just print out names and print out just names at 0, we shall see that this will give us John, like over here, and that there is no change due to names2. So names2 is now its own object with its own things to deal with, and names is now a separate object from any other variable, from any other array. And that's all well and good. Now, does anybody have any questions about like what's happening about like arrays so far? Wonderful. All right. Okay. So now this is, yeah, it's a fairly complicated way of copying arrays, but we have a very special class that can allow us to do this a lot quicker. So this is where the arrays class come in. So what this arrays class can do is simply just this. Instead of having this big block of code over here, can instead of having this for loop over here, what instead we could do is we can do names2 is equal to arrays dot copy of names. I believe that's the right syntax. I wrote it down over here just in case. Array class over here. So as you can see, we can make a copy of array 1. We just use the array name dot copy of, and then we get the array and array dot length. So over here, if we just do names and then names dot length, and we run it, look at that. John is still the same. And if we decide to print out names2 at 0, we can see that they're now both different. So this arrays class, which is imported using this, can easily just get a copy of stuff. So this is one way to do things. There's also a bunch more different methods over here in the array class, such as the toString method, which is also very useful. So if I do arrays dot toString and I do names, and then I do array dot toString of names2, we shall see that they are two different arrays entirely. Awesome, awesome, awesome. There's also plenty more stuff such as sort, which alphabetically sorts things, but I suggest that you guys go through these methods yourselves and just play around with them. These are honestly really helpful for other array content stuff. Okay, so now we've gone through arrays and we've gone through all of this other Java stuff. So now we're going to talk about the main thing with Java, and that is object-oriented programming. Or at least we're going to talk about just at least the tip of the iceberg in terms of object-oriented programming. Excuse me. So here's what we're going to do. Remember how previously with the reference variables, I was talking about how objects in Java are things that have properties and stuff. So let's create our own classes, which can then make objects. So let's create a new file. Let's create a dog object. Yeah, so let's say dog.java. Okay. So in order to create an object, what we're going to do is very similar to what we do over here. So we do a public class, and we're going to call it dog because remember, it's got to have the same name as the Java file. Okay. So over here, we have made our dog class. And so this dog needs to have, and so we know dogs can do like a whole bunch of stuff. They have a bunch of properties to them, and they have a bunch of different behaviors. And that's what methods are, and that's what objects are all about. Objects have identities, states, which are just properties, and which can change, and behaviors. It's just exactly what this thing can do, which are like what can this thing do? So our identity over here is dog. So we need to create some states for this dog, some properties for it. So let's create a string, and let's say the breed of the dog, and let's create also an integer for the age of the dog. Now you'll notice, so these are our states. So states, and you'll notice that these are not initialized, and that's for good reason, because we don't initialize them over here. We initialize them in what is called a constructor. So a constructor is written as such. It has the same name as the class, and it's got these brackets over here and then there. So what we do over here is we initialize all of our states. So we say breed is equal to, let's just say null. and let's just say the age is equal to 0. So this is what I would call a default constructor, where the initial values are pretty much filled with nothing, so 0 and null. But what if we wanted a constructor that was able to fill up these values? Well, we can create another constructor. Public dog, that's a fog dog, and we say string breed and integer age. So what's going to happen over here is that we are going to do this dot breed is equal to breed over here, and this dot age is equal to age over here. Now you may be confused as why I have I have this breed over here and this breed over here. Well, the way that Java is able to differentiate between the two, and the way that we are able to differentiate between the two, is by using this. So this dot breed is used to refer to the state, and this dot age is also used to refer to the state. Well, these over here refer to the constructor. So did anyone have any questions on this stuff? No? Awesome. Okay. So how would we use this constructor? Well, let me show you. So remember back in the date with the date reference variable, we do the same thing for the dog class. So what we do is we do dog. Let's give it a good name. Let's call it Fido. Say new dog. And this basically calls the default constructor. So we run this, and it's good. So the way we would call this constructor is by having a string and an integer over here. So the name would be Fido, and let's say his age is like 2 years. All right, very cool. Okay, and so this over here, oh, something happened. I have no idea what happened there. Oh, I have no idea how that happened. Let's just ignore it for now. So anyways, this calls this constructor. So then what's going to happen is that this dot breed will be set to this, and the state of age will be set to this. Okay, very cool. So now let's create a really basic method for this. So let's say we just have this public so let's create a method. So this method is stuff that we want this object to do. So we want this dog to, let's say it's barking, because dogs do that. So we do public void, and we do, let's call this method bark. So this is the basic syntax of it. We do public void, and then bark, which is the name of it, and then we have these two brackets over here. So what's going to happen is we want it to basically just give us what the dog would say. So print line, and it's just going to bark at us. Okay. And this should run good. Wonderful. So now how do we call this method? Well, we call this method like we had done with previous methods. So what we do, we use the reference variable. We do Fido dot bark, and there we go. We run it, and there we go. It barks right back at us, just like how we created it over in this method. Now, I also want to talk about this and this. So what we have over here is called a return type. So what a return type does is it returns to you a specific value. So in this case, because we have void, we basically return nothing to it. But what if we had integer? Well, let me show you. So let's say we had public get. Let's see, integer and we wanted to get age. Also important, methods use camel case as well for naming. So what you're going to do is you're going to return this dot age. So the return over here is what is used to return this integer. Remember, age is an integer. So if we do, so say we do system print line, do fido dot get age, what's going to happen is that we will get the age of Fido, which will be 2. Wonderful. Okay, cool. So now what about this part over here, these brackets? What do these mean? Well, this is where we can put parameters. Parameters basically allow us to get data from when the method is called. You can remove the keyword. You don't really need the keyword this for when returning. You are right. I don't really need that. So I can return age, and I will get bar, and I will get 2 just the same. So now let's talk a bit about parameters. So public, let's say I had void set age. And what this does is we do an integer over here and we call it age. Let's call it some new variable so that way I don't have to use this new age. And age is equal to new age. Yeah, so if I don't have a name that is exactly the same as this, I don't necessarily need to use this. So as you can see over here, I just said age equal to new age. So we run this just to make sure this code works fine. And so what I do over here, Fido dot set age, and let's set the age to 3 now. So initially it was set to 2 using this over here for this constructor. And then now we're setting the age to 3. So when we run it, what will happen is that when we get the age, we get 3. So yeah, so this is how you deal with methods and how you deal with their parameters. So yeah, and that's pretty much all that she wrote in terms of methods and all of this stuff. Now, if you want to go more into it, you can also look at like private for these variables, because sometimes it's good to private these variables and stuff, so that way they're not easy to access. So then you would use these get and set methods to change these variables whenever you wanted to, instead of using like dot operators. Because if I didn't have this private stuff over here, I could simply access this dot age using the things over here. So I could do this dot, so I could do Fido dot age and run it, and that would give me the variable. Oh, is it running into problems again? Oh, thank God. Oh. Well, I guess it decided to not do well with me, but that's fine. We basically covered all the stuff that we needed to. So I want to thank you guys all for coming today. If you guys have any questions and want to ask me, then please stick around. But anyways, thank you guys all for coming, and I will hope to see you soon tomorrow if you guys attend the post-secondary panel. Happy to see you there. So anyways, thank you guys so much for attending, and I hope you guys have a good night. Sorry for sticking around for quite a while. My apologies. But anyways, these if you need any help for the hackathon, don't please feel free to just ask me about like any Java questions. Always be here to help. Yep, you too. See you guys later.